We're going to talk about digital twinning today. And I want to specifically focus on a few things. Firstly, I would very much like to demystify digital twins. And as Ashish mentioned in his opening remarks, there is a lot of different views on what digital twins can be. And in my opinion, they're all right, because digital twins is a way of doing things. It is not a thing by itself, it's a way of doing things. And we will talk about what digital twins mean and how broad the applicability of digital twins are. We'll also talk about the right approach to embarking on your digital twin strategy in terms of how you implement digital twins. We'll also talk about a few use cases. And I want to we won't have much time, but I want to touch upon some of the architecture aspects of digital twins. And then, of course, we'll talk about open source and how digital twins can benefit from it. So it is going to be more of a stage setting type of event where we will talk about the broad concepts and try and bring alignment in the community to how we should think about digital twins rather than focusing on any particular solution per se. I'm Anand Micheri, co-founder and CEO of Invicara and Twinit. Invicara has the vision of Invicara is to create a platform for our partners, application developers, system integrators, engineering firms, and even enterprises who have their own innovation teams to create their own digital twin solutions. So Twinit is that platform, a platform on which you can compose solutions that address the business problems that you seek to address. Invicara also has announced last week at the Digital Construction Week in London an open source initiative called Digital Twin Factory, where we have open sourced a significant amount of building blocks for creating digital twin solutions for buildings, infrastructure, and cities. And Invicara will continue to contribute to this open source community. And the goal of that is to enable our partners and enterprises to create solutions more rapidly and take more control on the solutions that they're actually implementing. So that's about it from me as to my introduction. I'm going to focus more around the topics and talk through and clarify some of the questions you may have at the end. Feel free to use that QR code and connect with me on LinkedIn. Happy to be in contact with the industry professionals. Right. So with that said, let's delve into what digital twins are. So the first point is that digital twins can apply to literally anything in the physical world. It can apply to individual pieces of equipment, like a pump or a fan coil unit or an air handling unit or a chiller. So you could have a digital twin of that singular piece of equipment. Or you could have a digital twin of an entire system, like an HVAC system in a building, or a process. And the process can be a design process, or it could be a procurement process, or it could be a production process in a manufacturing line, or it could be a water treatment plant, the process involved in the treatment of water. Or it can be about places, and places can be buildings, any kind of building, aviation infrastructure, data centers, healthcare facilities, university buildings, or commercial office buildings, whatever it may be. Or it could be any kind of infrastructure, energy infrastructure, water infrastructure, road networks, rail networks. Or it can be entire cities with a number of subdomains. So you can imagine from that discussion, you can imagine how vast the potential of digital twins represents. And digital twins are really a knowledge graph of real world entities. And I'm going to spend a little time talking about it. I have a slide on it as well, because many times when we talk about digital twins, we conjure up impressions or visions of a 3D model and a game engine representation of something or something else like that. Now, visualizations, contextual visualizations are a very important part of digital twin solutions, a very, very valuable part of digital twin solutions. But digital twins are not just visualizations. Digital twins are at the core a data model that represents the world that you are twinning and also represents how that world is working, right? So it's in a way, and I'll show you, explain more detail, it's a knowledge graph, as it is referred to, of how the world works, right? So you can apply digital twin thinking to twin whatever your world is in the context of different systems, different processes within that world, and optimize that using AI, machine learning, expert systems, whatever it may be, right? So we'll talk about that. I also want to bring out a couple of interesting terms. The term around twinning is different from twin-enabled applications, right? They're two distinct concepts. They're very adjacent concepts, but different concepts. So twinning is about creating a world model, whatever your world is. Your world could be a manufacturing process, it could be a construction process, a procurement process. Your world could be the maintenance of an airport, whatever could be, whatever that is. So you have to first create a twin of the things you care about in that world, right? With the visual representations. And then you have twin-enabled applications that leverage that twin. So for example, if you are twinning an airport, you have an understanding of all of the, let's say, the maintainable equipment, all the systems, all the data relating to that, its locations, and so on. Once you have this twin created, you can use that twin to drive different use cases, different solutions. It could be asset management or maintenance management. It could be energy management. It could be people flow management or optimization within the airport. It may be about optimizing processes around baggage handling. So there could be several workflows that you could be dealing with. So the notion of twinning and the notion of twin-enabled applications are distinct things, but they are very related. And the goal should be ideally for enterprises to twin your world once and use that for driving multiple use cases. And that's really how we recommend our customers and partners to leverage this technology. Okay, so that was the sort of a high-level storyboard on what digital twins really mean. Now, we talked about digital twins being a graph of how your world works, right? And that's an important conversation. And as you can see in this diagram on the left, this represents the ontology of a fire management of a fire incident in a facility, right? Now, fire as a thing has got many classes of or many entities that define that management of fire as a process. You will need to know what are the different types of fires, what are the effect of fires, what are the causes of fires, and so many different aspects relating to that. So when you think about twinning something, and let's say you're designing a facility, let's say you're designing a healthcare facility, there are numerous processes that happens in a healthcare facility, and the design of that healthcare facility must accommodate all of those processes, the requirements of those processes. For example, you may have bedside assistance as a process. You may have code blue as a process. You may have decontamination or disinfection as a process. There could be numerous processes like that. Now, every one of these processes have different entities involved. There are people involved, there are process steps involved, there are assets involved, equipment involved, locations involved, various things. So you can represent any process, every one of those processes as a model, as a domain model, to represent, what are we dealing with here? What are the different entities we are dealing with? What are the different relationships between those things? What are the behaviors of those individual things? And what is the data we need to deliver that particular outcome? So digital twins are about defining your world in a way machines can understand, right? And one of those things can be a relationship to a graphical representation. It could be in a 3D model. It could be in a game, in an immersive game world representation. It could be in a photogrammetry. It could be in a PNID, depending on whatever you need. But we shouldn't put visualization and graphics at the center. You put the object at the center. And in this diagram, you can see the object called fire has got numerous entities that are affecting it, causing it, how we respond to it, and all of that stuff, right? So there are a few concepts. I know it's a little bit abstract, but I thought it was really important for us all to align around an understanding that digital twins in reality are an understanding of how our world works, how the physical world works. And an example of this is social media platforms, right? So all of you use social media platforms. And how do you think social media platforms know everything about all of us, right? So if it is LinkedIn or if it is Facebook or if it's Instagram, they all have their own business models, right? LinkedIn cares about recruitment and marketing and things like that. So the model they create about you represents entities that are related to their business model. Like for Facebook, it may be different. Facebook may want to know, who are your friends, where do you meet them, where do you go for coffee, and so on and so on. Google may have a different expectation out of that. So every one of these organizations create a definition of what an individual human means to them, right, from their business standpoint. And they use that information to continually build knowledge about that individual. And that's called a knowledge graph, a graph of data that represents everything about you. Now apply the same thing to something physical. That's the digital twin of a building or an infrastructure or a city. So to do that, there are a couple of concepts we need to think about. Ontologies, some of you may have heard this term. Ontologies are a way of defining the semantics or the defining the rules and the govern how things are called in that world. Like you don't want to call something in a certain context as X and call the same thing as Y somewhere else, or describe it in a certain way. Ontologies bring the definition of how you define that world. There are many industry standard ontologies. Some of you will be aware. Things like ontologies like BRIC. BRIC is a schema which defines everything about how a building operates, right? DBO is another schema, which is a digital buildings ontology, which was created by Google. This is another ontology. And then there are SARF and various other ontologies for cities and so on. So you could use some of those ontologies to help define the data architecture for your organization. And then define the domain models. The domain models represent the specific problem or the process or the use case that you are dealing with. And you could have multiple domain models. If it's an airport, for example, you could have domain models representing multiple processes within the airport. Gate operations may be a domain model. Baggage handling may be a domain model. Check-in and passenger flow may be a domain model. So maintenance may be a domain model. So bottom line, you create representations of or define the things that you care about in the context of a certain problem, and define all the relationships between all those things, define all the behaviors of those things, and the data and the data sources to bring those things together. So the fundamental of a digital twin is a domain model that represents the world that you are twinning. Ontologies govern it. By using an ontology, you have consistent nomenclatures, consistent definitions, and more standardization of your data architecture. And knowledge graphs is the example you see on the screen is essentially a visualization of either the ontology or the domain model, but ultimately also the application data, right? The domain model represents the things you care about, but then the application data carries all of the real-time readings that you're getting, all of the maintenance records, all of the process data. So the knowledge graph of the application data is massive, right? You can't just visualize it as a human. You could, but it's going to be very big. So you use APIs to provide the ability to query that graph and get information out of it to power your applications or your AI systems, as the case may be. So that was just to give you a sort of a deeper look into what digital twins really should be and how they should be created to power your applications. Now, how do you really build out a digital twin? The first step we already talked about: model the world you care about. Right, your world is distinct and unique to you, your organization, and the processes you want to optimize within that world. So define that world. We talked about how you define that world, right? And there are multiple ways of doing it. The next step is you connect information about your world to that definition of that world. You model that world. Now you connect information from that world to create a knowledge graph of that world, right? And this could be multiple things. It could be data from different enterprise applications, your maintenance systems, your ERP systems, if it's an airport, the airport operations database. It could be the flight data, the airline database of the respective airlines. It could be whatever, right? It could also be the BMS systems. It could be if it's a manufacturing plant, the DCS or the PLCs that manage the process of the plant. It could be IoT sensors, meters, and IoT platforms. And it could also be your models, your 3D models, either CAD or BIM models that provide you the structure of that world. So you define the things you care about in that world, and then you're taking the 3D models produced through the engineering process, design process, or construction process, and you're connecting the entities you care about to those graphical representations. So in the end, you get a knowledge graph that tells you how is your world structured, both in terms of data and in terms of graphics and visualization. How is your world working? Because you have defined what you need to understand about your world. So, and that knowledge graph is what is really powering your digital twin applications. The process of twinning is about really creating that knowledge graph of your world. And these are a couple of examples. So if your concern is, for example, a building, this is the real estate core ontology, or adapted from that. And what it's saying is that you have a portfolio of buildings. I want to identify every building in your portfolio. I want to know how many levels make up each of those buildings. I want to know what are the rooms within each of those levels. I want to know how are those rooms served by how are they organized into zones for delivering various services, HVAC or lighting or power or water or whatever. I want to know what are the systems serving each of those zones. I want to know what are the equipment that make up each of those systems. And I want to know the sensors that inform the performance of that equipment. So you can see in this domain model, you have entities, which are buildings and levels and rooms and zones and systems and so on. And you have relationships, what is part of what is serving what, and so on. And that domain model, when it is connected to data from the real world, it becomes your knowledge graph, which is what you see on the right, right? And this applies to not only buildings, it could apply to a city. This is the Saraf for City ontology, where you can see there are different subdomains, parking and mobility and environment and street light. It's just a subset of the whole thing, right? Just to give you and you can see the entities that are part of these subdomains are obviously specific to that domain. And if you take a healthcare facility, or if you take an airport, you will have different entities. If you take an energy grid or a water treatment plant, your entities are different, relationships are different, behaviors are different. So you define these things and you generate the graph. Now, you have defined defined the world that you care about. You have connected that world to the data that you're getting from the real world, and how that world is represented, created, and you've built your knowledge graph. Then what? So how do we then now make this graph available for your business applications? And that is what we talked about earlier, the distinction between twinning and twin-enabled applications. And now we are going to twin-enabled applications. And this could be literally anything in the entire life cycle of an asset. It could be applications or use cases in design, where you may not have real-time data, but in design you will have process definitions, you will have specific things or performance requirements that has to be met, and you will have some CAD data or BIM data coming together. And then you may expose that to machine learning models or AI systems to optimize. Or it may be something in construction. Maybe it is about planning or estimating or procurement. In any of these processes, the digital twinning approach is the same. You define your process, you define the things you care about, and then you bring that information through APIs to your expert systems that does that. So in this example, you're saying that the knowledge graph is exposed through APIs to consumers of that graph. And the consumer of the graph can be a web application, a mobile application, it could be a desktop application, it could be an AI model that does simulations, it could be a predictive maintenance ML model, or whatever, or it could be an anomaly detection system delivered through routes. So bottom line, you can, as a part of your implementation, you could expose these graph data to your consumers of that data, and you can also get the results back from whatever that application is doing and update the graph. So the graph is the living, breathing thing that is continuously representing everything you need to know, not only how something was designed or how it is working, but also about what are the predictions, what are the simulations, what are the scenarios. Your graph can have everything in a very organized way for you to interact with and make use of. And then, of course, comes visualization. So I did not intend to say visualizations are not important. They are really important, but we don't start with 3D models from when you talk about digital twins. You start by defining your domain. You start by defining your data sources. You start by defining your APIs and things like that. And then you bring in visualizations. And visualizations could come from, as we discussed earlier, CAD or BIM models. It could come from GIS, depending on what your world means to you. Right, so you could be dealing with a city scale urban development, and you want to know, obviously it has to be, you need GIS as part of that. But as the different assets are getting developed, you may want to ingest 3D models into it, and you may want to then leverage that for your use cases. So you could bring in CAD or BIM or GIS or game engines. So game engines are a powerful way of leveraging digital twins for visualization, because game engines, especially technologies like PixelStream, what it does is it generates a game world representation of your combined data set, your GIS and 3D models and everything, and renders it server side, which means you can have client applications that are delivering pretty intensive, heavy visualizations, but in a very efficient way, because you're only streaming pixels on the wire. So these are some technical aspects governing how you actually create performant digital twins, right? And that could be, again, driven by the use cases. If you're talking about a design review type of a digital twin, it could be very valuable. But if you're dealing with something more engineering oriented, you will probably need visualization, which is 3D model or BIM oriented visualizations, right? So with these first steps, you've actually created laid the foundations to build those user experiences that you need to deliver digital twins. Let me shift to, I know I'm covering a number of different topics, but the format of this is not ideal for me to answer questions right now, but please put your questions into the chat. We will have enough time for discussing your questions, and I think that will be very productive if we can do that. So let's take a capital program, a capital project, where you are utilizing BIM as part of the development process for design, coordination, for quantification and whatever else, and ultimately production of construction documentation. So that is anyway being done. Let's assume that, right? Let's assume that BIM is being used for production of construction documentation and help to improve quality and reduce risk and all of that, the usual BIM workflows. So that's anyway happening. Now, how do we use that to create a digital twin? So the first step is to know what use cases we want to address. This kind of relates back to my earlier slides around creating a domain model. And that's exactly what this is. Defining your use cases, building a domain model for each of those use cases, translating that to a design team or a construction team, informing them on the data that they need to provide, the classifications that they need to use, so that the things that you care about are called exactly what you want them to be called inside those models, inside those designs. Because otherwise, machines can't understand, right? Machines can't interpret, things based on what they look like. They need to be described properly. So once you define that, then during the process of design development, in your 3D design tools, there is an important requirement to classify those models correctly, define the data parameters to describe those objects correctly. You need to validate that data. So there are tools available, and as a company, while we were building the platform for digital twinning, which is the TwinIt platform, we also created applications or tools to help streamline data management in BIM, because it's really important to get good quality models for us to productionize the digital twinning process and have a reliable data source. So you can use tools to classify models, get recommendations. If something walks like a duck and quacks like a duck, you want to call it a duck, right? You don't want to call it something else. And you want everybody to call it exactly the same thing. So making sure they are correctly classified. And if it is something called a duck, what data do you need to know about it, right? Those parameters have to be defined. And that data has to be validated. It should make sense. These are important steps along the way. And then if you do all that, you can then take that data and create a project twin, meaning as the project is developing, could be in design phase, could be in construction phase, and your use cases are going to be very different during design, during construction, during operations. So you create that knowledge graph from that information about the data you care about, including the representations and the graphics and all of the related behaviors and relationships, and you use that to create your applications. And then ultimately, at the point of handover of an asset, the project twin continuously matures, because the information that you're going to get is going to progressively mature. At the point of handover, and managing handover is itself a process. It's itself an application, right? Digital twin application, where you can do digital witnessing, ensuring the commissioning management is done well, and the data that you need for operations are properly captured. And that results in an asset twin, which you hand over into operations. So, and once you go into operations, you enhance that by connecting it to the real world, getting data about how your world is working, and you could call that a performance twin. So, and these are steps in the twinning process, right? And this is the world model we talked about, creating that world model, and your world model will evolve over the life cycle. During design, your world model is something. During construction, your world model will have more data, and it will serve new use cases. And during operations, it's going to be different. Some examples, you could have during design, during construction, or even planning, you may have use cases around stakeholder engagement, simulation, optimizing your urban plan, for example. Or it could be about cost and carbon and schedule and procurement or progress monitoring, all of those kind of stuff. And ultimately, when it goes into operations, your use cases are more operations related. So that is the life cycle of how digital twins evolve alongside the life cycle of an asset development from planning through design, through construction into operations. So what are the use cases? Let's just take a little bit more deeper look at specific use cases. I've just listed a few here as examples, right? These are, I wouldn't call them detailed use cases. They're more like use case themes. Remote monitoring is a theme, right? Enabling asset operators to get situational awareness and have an incident response capability through an unified operations center, right? Creating a digital twin control tower for your portfolio, or for your, it could be buildings or infrastructure assets, doesn't matter what. Training and safety is a huge focus for many organizations. How do you onboard people? How do you make sure they're trained to do the job when they come on board? How do they get familiarized with everything? You're not going to pay for the mistakes and you will pay for the mistakes if they are not well on board. We all know that. So how do you ensure that? And that leads to also safety. Occupancy and wellness, more specifically commercial and residential buildings, where you want to ensure that there is good air quality available or made available for the occupants, for them to be productive and healthy. Carbon is a huge focus, and how do you track carbon across all? It could apply to all phases, from planning through design, more in design, I would say, than planning, some aspects in planning, and then in construction and also in operations. Maintenance is a very vast set of use cases, from predicting failures to detecting anomalies to extending an asset life and so on. And digital asset manual, we touched upon it earlier, which is an asset twin that you could create when a construction program or project is getting handed over from construction to operations. These are some use cases for buildings and infrastructure. If you talk about cities and urban developments, some of the use cases would be around remote master plan visualization. So you could have many stakeholders involved, right? So how do you engage those stakeholders, whether it's investors, tenants, regulators, communities who are part of that? How do you engage them? So we are involved now, even in some existing cities in North America and in Middle East, where there are several new cities being created. These are some very important use cases for them. How do you make sure that you understand what is the urban plan? I'll show you some images as well. So flood simulation, planning, public safety is a huge topic, including things like command and control. It could be also even pollution and things like that. Traffic management, construction site monitoring. So there's a whole bunch of use cases around cities and urban developments that you can implement. And then you could also have sector-specific examples. If you look at manufacturing, we talked about digital twins being applicable to individual equipment. So manufacturers, let's say a manufacturer of a compressor, instead of selling the compressor or a chiller as a capital purchase or a capital purchase for the customer, they could make it available based on usage, right? If they have to do that, then the manufacturer has to know where each and every one of their equipment is. How is it performing? Do I have spares? Where are they? Do I have people certified to go and solve a problem? Is there an issue? Has it been resolved? What are what follow-ups are required? And the service level being maintained and so on. So servitization of equipment is a major use case. In aviation, there are so many different use cases in master planning and development. And these are just themes. We have more detailed definitions of use cases within each of those themes, whether it's master planning development or airport operations, facilities and real estate, and so on. Healthcare, obviously, there's tons of use cases around improving patient care, tracking impact of treatments, even twinning an individual human being, right? In terms of how that human is responding to treatments over time and managing the treatment protocols over time. Energy utilities, everything from scenario planning, training, and so on. Communication, network planning and network operations for telcos, water utilities, optimizing chemical dosing, optimizing energy use, reducing backwash cycles based on the turbidity and whatever considerations to reduce the energy use, demand forecasting. There's lots and lots of use cases. So you can imagine from this that digital twins are not one thing, right? So digital twins are really digital transformation vehicles. Digital twins power digital transformation. It's not a thing by itself. So you can take you can within your own domain, within your own sort of industry vertical, you can select the problems you want to solve, where you want to transform with data, and you apply the digital twin thinking to create that knowledge graph representation of how your world works, and then you use that to drive applications that actually transform and achieve the goals that you're trying to achieve. Which is why, as a company, we built a composable platform that is what we call unopinionated, meaning we don't define what you can do with that platform, what kind of asset or process or system you can twin, or what use cases you can deliver. We created this orchestrated set of services, platform services, that can be configured by writing scripts to create the solutions that you need. And like with digital transformation, in any digital transformation exercise, requirements evolve over time. You start doing something and then you realize what more you need and how you want to fix it. So there needs to be recomposability, right? You need to be able to enhance the solution and adapt the solution to meet your changing requirements. Continuous improvement, right? Like with any quality system that you use, continuous improvement is a key part. And digital twins need to support that. Right, and these are just some use cases, just some screenshots just to show you how you can actually, this is just showing the roll-up of maintenance data across a whole portfolio, bringing information from different maintenance contractors' systems, and giving the organization a visualization of how things are. And from there, you can go down to the individual building an asset and look at the things that are so it can take you down to any level of granularity you want, but equally for certain users you can create customized experiences that give them the level of information that they really care about. Occupancy and wellness and air quality, this is typically for offices. You could have several use cases that are space related, where you want to do heat mapping, or you want to do based on different types of data, or you want to know simply locate, or maybe it's a safety thing. Like if you have a fire alarm, you want to know where exactly is the fire, where is the fire spread happening, how do you access that place, use cases like that. In urban planning, large city scale implementations where, or even before the city is built, right? Even it's in planning, it's in planning, but you want to assess the livability of that city. You want to enable a potential investor to compute the travel time between a location of an asset to certain services within that development. You want to be able to allow, if there is a redevelopment, you want to allow the community to understand what the redevelopment is going to look like, and they can then provide back information. You can model the economic data, the demographic data, and understand the economy and give more visibility to what the economy of that urban development is going to be, so that investors can better understand how they can participate in that economy. And in this, you can also create solutions that integrate the 3D experiences, and you can also the immersive experiences with game engines and so on. Carbon tracking could be another. This is an example of how you track the embodied carbon in designs as they develop with large programs, and this is an example of that. And this can go down to identifying the carbon intensity of specific building elements in design, so you can then focus on redesigning them or making decisions with data. You make deliberate decisions on design based on the carbon intensity. Again, geospatially distributed assets around construction tracking or whatever else. So that hopefully gave you a good sort of overview on digital twin applications and the approach towards it. And I now want to spend a few minutes to sort of dig a little bit into the architecture of how you implement solutions, and then very quickly then we will go to the Q&A. Do populate the Q&A box in the meanwhile. So there are three ways of implementing digital twins. One is exactly what problem you want to solve, right? Precisely what problem you want to solve, and you find that there is a commercial off-the-shelf product to do that. For example, to do a daylight analysis of a BIM model, or you want to do a energy analysis of a building using a BIM model. So there are tools that are specifically designed to do that. So you have pre-baked products that are designed to do a certain things, and you could use those things to solve that problem. And that is one type of a digital twin. It may not fully meet all of the definitions of a digital twin, but if you say that I want to take a digital representation and do some simulation and give you a result, and that is a digital twin, that could be a digital twin. And then in that case, the pre-baked products would fit that. Or you could build full stack custom solutions. So you may want to have leverage multiple platforms to do that. So there could be a platform that supports data modeling or domain modeling. You may have a platform for doing 3D visualization. You may have a platform to do your data pipelines and integrations. You may have another one to do your authentication and permission models. So, but you still need to build a full stack application that sits on top of many platforms and orchestrates those APIs and deliver that value. It can be much longer to build these solutions. It can be more expensive. It can give you flexibility. You can deal with it the way you want to, but it is your time to value could be very long. Or you look at composable architecture as an approach. Composable architecture literally means that you use a platform or a system which has building blocks that you can configure into a solution. So think of them as fungible. I like to use the term fungible Lego blocks, right? A Lego block is obviously rigid, right? Imagine you have a kit of parts that you can actually modify, right, in terms of the shape and size and so on. So software is like that. So you could use a platform like TwinIt, which is the platform we built, the first such composable platform in the industry today for digital twinning. So you could use those building blocks to rapidly compose your solution, and therefore you can also recompose them as your requirements change. So that's a powerful way to build these solutions and achieve quicker time to value, reduce the lifecycle costs on maintaining and updating them, address your cybersecurity concerns more easily in this approach, and so on. There's several benefits to it. So those are some concepts around how you implement them. Now, composable architecture, it really helps in the end. It helps you to balance your cost and performance on one hand. On the other hand, enabling you to invest in outcomes and then innovate and grow the business. Gartner, the research firm, calls this the future state enterprise architecture, right? And this is a very powerful statement. If this is how the future IT is going to be, right? Composability, composable architectures are going to really transform how IT investments are made, and we apply that in the context of digital twins. Now, the last topic I want to touch upon is open source. And many times when we talk about open source, so think about using composable architecture together with open source. That's really the power of what I'm talking about. So what is open source? There are certain things that govern what it is and certain things that it is not. Open source means it is free to use and redistribute. You as a implementer of a solution or as an enterprise using a solution, you could use software for free and create and redistribute it commercially. The source code could be distributed, as source code or in a compiled form as part of your application. You can derive works from it, create your own IP, but it all driven by the license. So we announced an open source program called Digital Twin Factory last week, where we open sourced all of our, like I mentioned, all the application building blocks, and we made it available through an Apache 2 license. Apache 2 license is one of the most permissive licenses that allows you to take it and create your own intellectual property, your own commercial offerings, and so on. It's community driven, so there is a lot of collaboration around that. It's not necessarily always free because there could be whoever builds an application, a solution for you as an enterprise, using open source as the background, and they will probably still need to support and host and advance the features and so on. So there'll still be some cost. It's not proprietary. Definitely, open source is not secret. It's open for scrutiny, which also does not mean it is uncontrolled. There's a lot of governance around it, quality, security. You can use it for commercial use, and it is actually secure, if not more secure than proprietary software, because it's open to the community and it's transparent. So we would think that open source is a very powerful way for enterprises to leverage leverage flexible solutions or build flexible solutions, leveraging a composable platform as the compute layer. So use a composable platform as your compute layer. You leverage open source at the application level. So all the background is open. All the foreground is something you pay somebody to get built, so you still own it. So it becomes a very powerful way of managing your outcomes. So open source drives cost savings, drives fast innovation, positions you better, enhances the reputation. Joining these communities attracts you talent. It builds your brand, gives you more customization and flexibility, and of course, it gives you more higher quality assurance because of the open scrutiny around it. So this was the Gemini principles in the UK, which is the National Digital Twin Program. And if you see several of these expectations of the Gemini principles are really best served or best achieved through open source strategies at the application layer. I know I covered a number of different things there, and thank you for being patient. Hopefully that was useful, but now let's turn it over to you all for the questions.
Okay, Anand, very, very insightful presentation that you made, and there are a few questions on the Q&A box. Once again, I appeal all the participants. Good response from people. We had almost 280 registered and good response. I would request those who are attending, if you have any questions, please post it in the Q&A box. I will go through it, pick up if it is very relevant to today's topic. I'll just take the first question from Abraham. His question is, when I build the twin at the ontology phase, if I do not have 100% details, and if I get the same after the defined period of time, how will I be able to add or update as and when the details of my data grows?
That's a very good question. It's an incredibly good question. And the way I would answer that is, you can take one of two approaches, right? So if your domains that you care about can be fully addressed by an existing mature ontology like Brick, then you would use Brick to compose your elements or entities in your domain model. But sometimes you don't have the ontologies that are fit for purpose for your specific industry vertical or the problem you're solving. In which case, I wouldn't think that you would go and boil the ocean and try to figure out all of the knowledge that you need to know about that field. You would start by building your domain models, right? But then as you're building your domain models, you would promote those entities in your domain models to your ontology, so that when those entities are being used again, you will have the same semantics being applied to that entity the next instance when you use it. So it's an approach of building a domain model and building an ontology by informing the requirements of the ontology when you build your domain model, but you also conform to the ontology for the things that you've already built. So it's a kind of a iterative approach, a co-creation approach between creating your domain models and your ontologies. Hopefully that gave a reasonable explanation. The next question is digital twin implementations, use successful case studies. So there are numerous, and this could be across several domains. In aviation, there's a lot of use cases. Commercial buildings, there are a lot of case studies. There's also around in healthcare, but you will find that every one of them are a little bit different in terms of the use cases. Commercial buildings, the use cases are going to be very different from the use cases you will find in a healthcare facility. There are some common themes around maintenance, asset management, energy management. So those use cases, you will find them fairly consistent across all types of buildings. But when it comes to infrastructure, they're going to be very specific to the type of infrastructure. So water treatment plants, we'll be looking at optimizing chemical dosage or optimizing backwash cycles to reduce energy use and things like that. Hopefully that answered. Another question there, which is also very interesting. How is a digital twin created for an existing building? And I think we talked about that, right? I mean, it's kind of implied, but I'll make it more explicit. We shouldn't necessarily think about 3D modeling as the starting point. And that question to me lends me to understand or believe that the assumption there is, do we have a rich 3D model of that existing building in order to create a twin? You don't need it, right? If you have it, great, but it's not a must. You can start by defining the things you care about in that building, defining the relationships of those things, the behaviors of those things in a domain model, and then you use graphical representations. It could be 2D schematics that you relate the objects in a 2D schematics to your entities that you care about, or it could be photogrammetry, or it could be Or you may scan the building and create a model and use that. So you can take, and in existing buildings, you generally, you're more careful in assessing what is it that's going to really move the needle for me, right? And they focus on them, maybe the more higher energy consuming equipment, or the equipment that really impacts the performance of the building and the occupants and so on. So yeah, I think the next question was about benefits of digital twins, and I think I covered that. Can BIM be the source or be the first step to a digital twin? Absolutely. There was a question from Vinayak. Yeah, absolutely. If you have a new asset, and you have a good BIM process, but we have to make sure that the BIM process considers the requirements of a digital twin. Many times what we see is the BIM process is only meant to serve the design workflows or construction workflows. The designers or contractors don't fully visualize or are not informed about the requirements for digital twin use cases and operations, for example. So digital twins can only be materialized from BIM if somebody thinks through what the requirements are in the BIM process to deliver a digital twin. And these needs to be defined as contractual deliverables, right? Because otherwise, if something is not defined as a deliverable, no one's going to cost for it. No one's going to do it. And then expecting that somehow it happens automatically is not going to be a good idea. So you need to have a strategy, define the requirements, communicate it, make sure that it is part of the scope, it's costed for, and then you will get the outcomes that you're looking for, and you can use BIM to do that. Another question from Vinayak, which is, can we simulate and test systems to the digital twin? Yes, absolutely. So when you talked about domain modeling, you can incorporate within the domain modeling behaviors of each of those entities, performance spec around those. And then when you're actually testing the performance during commissioning, or even continuous commissioning, if you want to implement continuous commissioning, that's exactly how you do it. You define your performance requirements as behaviors in your domain model for those entities. And then you look at the real-time data and you find the anomalies, and then you use that to generate work orders for somebody to go back and do something about it. Is there any open source? That's a question from Minu. Is there any open source available to create knowledge graphs? Yeah, so there is, creating knowledge graphs requires a number of things. Like creating a graph per se, it's not like doing a mind map, right? So you need to define the semantics of objects. You need to define the data sources. You need to define behaviors and so on. You need tools for that. So our company, TwinIt, the platform that we built, provides something called a TwinIt Workbench, which allows you to build these models, domain models or ontologies, and visualize them as a knowledge graph. The knowledge graph is the result, is the visualization. The modeling is what you need to do to generate that graph representation. Another question from Minu. As you mentioned, the example of daylight by using the building knowledge, create a 3D modeling and use the tool to get results. What are the further steps to make it full stack DT? Now, if you use a point solution, right, a product that is designed to do a certain job, and expect that somehow it will become a flexible digital twin to do other things, my recommendation is don't. It can't. Software doesn't scale like that. You will need to necessarily think in terms of using a platform to compose those flexible solutions. You could take the results of those point solutions and bring that in as a data source into your platform. But those tools themselves are designed to do certain specific things, and that's all they will do in general. Rupa Patnaik, the question is, in digital twinning, what are the specific design requirements for harmonics control from equipments? If any specific requirements for harmonics control from battery swapping in EVs and parking lot technology? I'm not a domain expert around EVs and harmonics and electrical engineering, so apologies, I can't answer that question. You'll probably have to consult with a electrical designer, and of course there could be a conversation together with a digital twin expert around leveraging that knowledge. And this is, in fact, this is case in point. creating, defining these things is really a consultative approach. You need a expert knowledge of a domain to create digital twins. Digital twins are not created by software companies. Companies like us provide tools for engineers who know the domain to create solutions, right? And we build powerful software, but how you use it in your context, and this is a great example of that, you will need a domain expert to be part of that team creating that solution. Question from Denzel, as a builder, can we connect all our projects and use for command control using DT? Yes, absolutely. That's remote monitoring. That's a perfect use case. Another question from Denzel, can digital twinning be applied for a command control for fire monitoring? Absolutely. Including video monitoring? Yes, you can. These are very, very classic use cases around that. And lastly, change of design. So yeah, so you can create digital twins, question from Venugopal. So you can use the digital twin solution to track changes to designs as it progresses. And those are all typical use cases per se. I suspect we are out of time, so I'm not going to continue. And there are no more open questions, I think.
Yeah, Venugopal has been raising his hand quite often. I thought if you can unmute, probably I'll allow you to speak, Venugopal. If this question is already answered, then you can lower your hand. Venugopal, if you're there, please unmute and speak.
And meanwhile, there's another question from Naresh Kumar. Will data from sensors and actuators in the real world trigger alarms in the digital twins as a precursor to physical? Yes, absolutely. So by defining the behaviors, expected behaviors of your entities in your digital twin, you can assess that against the real-time data. You can be rules-based, it can be machine learning-based, but definitely digital twins can detect and notify these sort of anomalies and even recommendations for improvement as part of your solution.
So with that, I think we conclude the Q&A session for today's webinar. And I want to thank Anand, who joined from Dublin, Ireland, to address the gathering today. And I'm sure a lot many have benefited. And this recording will be available. And we'll see how the response is. Then probably we'll have a second session on this sometime in August or September. And those who are yet to know about Focus, we have in the chat box, we have mentioned about what is Focus, the website of it. And I'm sure everybody who joined are a construction professional, maybe an architect or a PMCs or facility managers. I would request everyone to enroll as a member. It's just 1,500 rupees as a member fee, I would urge. So finally, I'll allow our president of Focus to give word of thanks and the concluding remarks of today's webinar.
Thank you. Thank you so much, Dominic. And thank you, Anand. That's wonderful. Absolutely. Even I learned a lot on the webinar today in terms of what is digital twin, what can it do? And I'm aware that you've been doing in the developed markets where you are operating currently, these are actually being put into use. In the next webinar, we'd like to learn about some of the applications that you are already doing it. I think the case studies and applications, something that we love if you can do the webinar on next time. But again, thank you to everyone. Please do become a member of Focus. Thank you for joining this afternoon, and to our speaker also. And have a great day, everyone. Thank you.